I'm exploring the effect of the alpha parameter on the kernel ridge regression model in sklearn. Think of kernel ridge as a fancy curve fitting tool. Alpha is a key knob we can adjust. I want to understand how changing alpha affects the model's performance, its smoothness, and its tendency to overfit the training data. This is the regularization parameter, specifically L2 regularization, in kernel ridge. It controls how much we penalize model complexity. A higher alpha means a stronger penalty for complexity. Alpha directly influences how complex the model is allowed to become. A larger alpha forces the model to be simpler, preventing it from overfitting. Think of it like a constraint that prevents the model from getting too wiggly. This is the crucial concept here. Increasing alpha reduces the model's variance, sensitivity to training data noise, but might increase its bias, difference between the model and reality. It's like finding a balance between accuracy and generalization. I'm going to explain the impact of the alpha parameter in the sklearn's kernel ridge regressor. It's all about controlling how much the model trusts the training data. Too much trust leads to overfitting, too little trust leads to underfitting. We want to find the perfect balance. This question asks you to understand how the alpha parameter influences a kernel ridge model, which is a type of regression model used to fit nonlinear relationships. Think of alpha as a tuning knob. We will evaluate its effects on the model's bias-variance trade-off and how it impacts model's fitting process. You'll assess the validity of different statements about how changing alpha impacts the kernel ridge model. Let's find the true statements. The options will involve model smoothness, sensitivity to data points, overfitting, and the relation of alpha to kernel complexity. This statement reflects the trade-off between bias and variance in machine learning models. Increasing alpha means stronger regularization. I can say that it penalizes complex models, which makes the model simpler and smoother, lower variance. But this simplification might introduce higher bias, inaccurate predictions. This is false. Increasing alpha actually reduces a model's sensitivity to individual data points because regularization smooths the model, making it less responsive to outliers or noise in the data. This is true. Lowering alpha reduces the strength of regularization. This lets the model fit the training data very closely. If you have a complex kernel, it can easily overfit, learning the noise of the training set rather than underlying pattern. Incorrect. Alpha is a regularization parameter. It controls the complexity of the model's fit to the data, not the complexity of the kernel function. You choose the kernel separately, e.g., RBF, linear. Alpha then dictates how strongly the model adheres to this chosen kernel. This section introduces the core topic, how the alpha parameter affects the kernel ridge regression model in sklearn. We'll be investigating how adjustments to alpha influence the model's behavior. Think of alpha as a tuning knob. We're asked to identify the true statements about the effect of alpha on the model's performance. I'm going to help you understand each choice carefully. This statement is correct. Increasing alpha strengthens regularization. Regularization smooths the model by reducing sensitivity to individual data points. It means less flexibility, leading to lower variance, less fluctuation in predictions. However, this simplification might introduce bias. The model might not fit the true relationships as well. Think of it like simplifying a complex sketch with more sweeping lines. You lose detail, higher bias, but the picture is less shaky, lower variance. This is incorrect. As I mentioned before, a higher alpha actually reduces this sensitivity, leading to a smoother and less variable model. It's the opposite effect of what's claimed here. This statement is also correct. A smaller alpha means less regularization. This allows the model to become highly complex and fit the training data too closely, overfitting. It will perform poorly on new, unseen data. This problem is particularly noticeable with complex kernels, which are already capable of learning intricate patterns, thus making them prone to overfitting with weak regularization. This statement is false. Alpha does not control the kernel itself. It only controls how strongly the model is regularized, how much the model is prevented from overfitting. The choice of kernel, like RBF, linear, or poly, is independent of alpha. I see alpha as a tuning knob. It controls how much I penalize a complex model. A larger alpha means I strongly prefer simpler models. A smaller alpha means I'm more lenient, and potentially riskier. Think of it like this. A large alpha is like saying, keep it simple, stupid. While a small alpha is, let's try to capture every little detail. This is the main topic. Understanding how alpha affects the kernel ridge regression model. Kernel ridge is a powerful technique for modeling nonlinear relationships in data. Alpha directly impacts how well it smooths the model and avoids overfitting. When I decrease alpha, I reduce the penalty for model complexity. This allows the model to become more complex, potentially overfitting to the training data. It's like trying to fit a curve through every single data point. I might get a perfect fit on my training data but do poorly when given new, unseen data. When I increase alpha, I increase the penalty for model complexity. My model will become simpler, smoother, and less sensitive to noise in the training data. While less flexible, this simpler model is less prone to overfitting and can generalize better to new data. It's like drawing a smooth line through a scatter plot. Not every point is perfect, but it captures the overall trend effectively. This refers to the specific machine learning model we're using, kernel ridge regression. It's a powerful tool that uses kernels to handle complex relationships between variables while also employing a regularization technique, controlled by alpha, to prevent overfitting. This is the title of the problem. We'll be focusing on how the alpha parameter affects the kernel ridge regression model in sklearn. It's all about understanding regularization and its impact on model performance. This sets the stage. We are presented with a multiple-choice question and need to determine which statements about the effect of the regularization parameter ALPHA on a kernelridge model are correct. I see this statement as addressing a key consequence of reducing ALPHA. A smaller ALPHA means less regularization. That means the model is free to fit the training data very closely, possibly picking up noise and details specific to that data. This is overfitting. This is especially true with kernels, the functions that define how the model measures similarity between data points, that have high capacity to capture detail, which allows the model to fit the noisy data very closely. This statement tests your understanding of regularization. I find that it's incorrect. Increasing alpha increases regularization, which in turn makes the model less sensitive to individual data points. The model focuses more on the general patterns instead of being thrown off by unusual data points. This is about the bias-variance trade-off. I see that increasing ALPHA strengthens regularization, leading to simpler models. Simpler models are smoother, less sensitive to noise, lower variance, but might not be able to capture intricate details, higher bias. This section title hints that this part will deal with the core idea behind parameter ALPHA, which is regularization. Regularization is a way to prevent overfitting. This section title introduces the concept of regularization in the context of the ALPHA parameter. I see ALPHA as a tuning knob in kernel ridge. It controls the strength of L2 regularization. A larger ALPHA means stronger regularization, which penalizes large model coefficients. Think of it like this. A high ALPHA makes the model less sensitive to individual data points. It forces the model to find a smoother fit overall. A smaller ALPHA does the opposite. This question tests your knowledge of how ALPHA, the regularization parameter, affects the kernel ridge model. We'll carefully examine each statement to see how ALPHA influences things like model smoothness and sensitivity to individual data points. This is absolutely correct. If I decrease ALPHA, it's like loosening the reins on the model. With a complex kernel, that model can now fit the training data extremely closely, even its noise. This close fit on training data means it'll likely perform poorly when faced with new, unseen data. That's overfitting. Increasing ALPHA makes the model simpler and smoother. That's because larger ALPHA values strongly penalize complex models. You'll get lower variance, meaning less sensitivity to random fluctuations in your data. But the model's overall accuracy, bias, might suffer slightly to achieve that smoothness. I'll say, that's incorrect. The ALPHA parameter doesn't affect the kernel itself. You choose the kernel, like RBF, linear, or poly, separately. ALPHA only impacts how well the chosen kernel fits the data. Think of it like this. You select the type of paintbrush, and ALPHA determines how precisely you use it. This statement is false. Actually, it's the opposite. A larger ALPHA makes the model less sensitive. That's the entire point of regularization, to reduce the influence of individual data points. The model becomes more robust to noise, giving you a generalized smoother fit. This is the main question. It directs you to assess the effect of ALPHA on the model. Remember that we consider the true and false statements in relation to the effect of alpha.